At a remote space center in northern Finland near the Russian border, researchers are studying how climate change is impacting the Arctic region with more precision than anywhere else in Europe. Slowly turning like sunflowers towards polar satellites in space, 4 large antennas dominate the snowy Finnish Meteorological Institute's Arctic Space Center in Sodankyla, a small town of 8,000 inhabitants just north of the Arctic Circle. Situated amidst forests, peatlands and snaking rivers, the research space has become a unique site due to its history of obtaining data on weather and climate. By using both ground measurements and satellite data, researchers have been able to study how the snow and ice cover in the Northern Hemisphere has changed over the years. Some 550 different measuring devices are scattered across the observatory site, including several instruments attached to a 25-meter, 80-feet tower in a pine forest, monitoring greenhouse gases from trees, soil and atmosphere.
We are here in the edge of the Arctic, in Sodankyla, about 100 kilometers north from the Arctic Circle. This is an excellent location for studying the boreal forest, the environment here in the Arctic, and utilize the satellite data for observing the climate change, the nature, and all the aspects of this fragile environment. Sodankyla is one of the most equipped one and the best equipped one in the area, and satellites are the best way to observe the vast Arctic, to have the holistic view what happens in the entire Arctic. Measuring carbon dioxide on top of the snow from the satellite, atmospheric carbon dioxide on top of the snow from the satellites, is very, very difficult. That's why we are here to measure and compare the satellite measurements in the Arctic area in the winter conditions, to allow us to develop better methodology for detecting the carbon dioxide, atmospheric carbon dioxide from the satellites.
Sodankyla's ground measurements have played an increasingly crucial role in supporting Europe's satellite observations, tracking the changing climate in the Arctic.
Here it is, we're calling tower called ICOS tower, the tower that we are using for hosting different satellite reference instrumentation. From this tower we are measuring the carbon flux of this environment, the trees and the soil, and then we are also having instruments mounted on top of the tower that we are using as a reference for soil moisture and ozone salinity emission and different SAR missions, satellite missions.
According to a study in the journal Nature, the Arctic has warmed nearly 4 times faster than the globe since 1979.
There is a cliche that what happens in Arctic doesn't stay in the Arctic. So that means that the changes we see here, the melting permafrost, the temperature rise, will happen in other places also. It just happens here faster.
The average temperature had trended upwards at double the speed compared with other parts of the world since measurements began on the site in 1908, as a result of human-induced climate change mostly blamed on fossil fuels.